Okay, I want to do one last example of calculating the slope using the limit definition of the derivative. So I'm looking at the curve y equals 1 over x, and we want to know what is the slope right here at 1, 1. What's the slope of the tangent line? And so we're going to write down the limit definition of the derivative again, which I'll write as limit as h goes to 0 of f of x plus h minus f of x all over h. And now I'll write down what f is. F is 1 over x. So I should have 1 over parentheses minus 1 over parentheses all over h. And the first one should be f of x plus h. So it's 1 over x plus h. And then the second one is minus f of x. So that's just 1 over x. And now I need to add those together. To do that, I need to get a common denominator. So I'm going to take this to be the limit as h goes to 0. I'm going to leave myself a little bit more room here. So I have 1 over x plus h minus 1 over x. And to get a common denominator, I'm going to multiply by x over x. The first expression by x over x. I'm going to multiply the second expression by x plus h over x plus h. Okay, so I get x over x times x plus h minus x plus h over x times x plus h. And now since I have a common denominator, I can actually add those together. So this is going to be x and a minus x, and I'm going to get a minus h when I distribute that negative sign in there. So this is the limit as h goes to 0 of negative h over x times x plus h. And then I'm dividing by h, which would be the same as multiplying by 1 over h. So just to make this, instead of having this on 3 lines, I'll make it on 2 by multiplying by 1 over h. Okay, and now the 1 over h and the negative h cancel, and I'm left with the limit as h goes to 0 of negative 1 over x squared plus h times x. And now I can actually let h go to 0 here. So I take that limit. This will actually go to 0, so I'll get 0 times x there. So I'm ending up with just negative 1 over x squared. So I just found that my slope at any point on this curve, x comma y, is dependent on x. It's going to be negative 1 over x squared. And I can now plug in 1 comma 1 into this expression to give me the slope right here. Maybe I'll do that right in green. So m of 1 comma 1 is negative 1 over, and I'm plugging in 1 for x. So 1 squared is 1, so I get negative 1. So that tells me that the slope here is negative 1. Right there. If I wanted to find the slope somewhere else, like here, which would be 3 comma 1/3, the slope I can already tell you will be negative 1/9, right? So m at 3 comma 1/3 is going to be negative 1 over 3 squared, or negative 1/9. So that's the beauty of calculating the derivative, is it gives you a function that tells you the slope at any point. I could even plug in, negative 2, and it should tell me what the slope is there. M of negative 2 negative 1/2 is going to be negative 1 over negative 2 squared, which is negative 1/4.